Just like with all the other assignments, let's read the instructions and be sure that we understand the questions and then tackle the questions one at a time. With this assignment, what I need you to do is to be able to plot with the first question a pie chart like this and reveal all these features, labels in terms of percentage of the pie slices, except this one here that says sample. This is a picture. Are we together? So I've pasted the picture of a solution so that you can now give me a chart there, not a picture. You go to the bottom one. Again, you are given two things, voltage and current values, and you are supposed to plot a graph like this, where you are not supposed to join the dots. You put the graph in there and then you put the regression line or the best fit, as you normally do in experiments. You will then be able to reveal the equation within a click of a button. The third one, we are given three things, voltage, current, and power. And you're supposed to plot everything onto one set of axes. On the left-hand side, on the left, y values will have to be current. And on the right, y values, it will have to be power. So you're plotting current against voltage and power against voltage. So this is called the primary axis. And this then becomes the secondary axis. You can't put both of them on one axis because let's just look at an example. This one ranges, current is from 0 to 40, whereas power goes from 0 to 800. So it means if you had left them on one side, then the current graph was just going to be there on the bottom. So hence you need to have different scales for current and for power. Lastly, I'll show you how to do a graph of trig functions. Now I'll make use of simple trig functions that you know, sine, cos, and tan. I believe in showing you the simpler things so that then you can grow the knowledge to more complicated ones. I'm just going to highlight, is insert, and we go to the type of graph right there. You choose a graph, this time you need a pie graph, and you press insert. But surprise, surprise. You click on that, and that's all you get. Why? There's the order in which you need to present your data. You need to have the list first, followed by the data. So these values must be on the right-hand side. If you don't have it like that, it can still be done, but it will take you ages because then you've got to change the order within settings, which takes unnecessary time. If the label and everything is fine, all you do is insert pie graph, select the pie graph, and within one click, the graph is there. The same thing can be obtained. You'll see that if you've got the labels on top and data at the bottom, you still can get the same graph. So it allows you to do that. Right click and say add data labels, and you've got data labels, although they're in the wrong format. But these are data labels. So you can still select it from there. Of course, there are shortcuts in most of these things. I said the pie slices must be arranged from the smallest to the largest. What you do is you sort the data, not the graphs. You highlight this, and then you go to data, sort, then you can sort by salary, isn't it? Sort by salary from largest to smallest. Okay. The next one, you need to plot a graph of voltage against current. Once again, you just highlight. You need to plot a scatter graph, not the line graph. So you insert, instead of a line graph, you go to scatter graph. So you can go in here and select this one, and already it looks more or less the same. I'm just going to put that there, put this here so that you can see. Now, let us look 0 all the way to 25. Here we've got 0 to 40. 0 to 25 is on this axis, 0 to 25. So it flipped the axis around. So how can we correct that? Swap the columns. It's as easy as that. Copy this one. And then plug it here. So now we've got IV. Why? Because it needs X before Y. Now you highlight them, insert, scatter graph, and this time it's exactly what we expected. Note that when you click on this graph, these things are objects. You can resize them. Do you see that? Including, you can even insert text boxes. There's a text box. You can insert it here and say voltage. And the voltage was in volts. Now, this text box, you see there's a green part over there. So this green thing, you can click on it, hold the mouse, and you'll get the arrows. And then you can just rotate it to how you want it to be. Then you can drag it, put it there, click, put it whichever way you feel you've got to do it. Again, at the bottom, you can then insert a text box. This one is current in amps. Resize the text box. Click, pull it where you want it to be. You don't want this thing which is called the legend. Click and even delete. Sometimes I want you to change even the grid lines. You can just right click on these ones and say I don't want any lines, or I want lines. So feel free to play with these things. We need to say V, what did it say? V versus I. So that's what I did there. We now need to put the regression line. So if you've got to right click, where do you right click? The data points. You can't just go and right click there. On the data point, you right click and then you get add trend line. Simple as that. Click add trend line and it asks you, what did you expect? A line, an exponent, a log, a polynomial, a power law, moving average, or what? You know that was supposed to be just a linear relationship. So sometimes I give you something like y is equal to 5 exponent something. And then I say put a regression line. You can't put a linear because I said y exponent blah blah blah. Or sometimes I put it in between or in my instructions to say viruses increases exponentially to blah blah blah. Then you need to know that the regression has to be exponential. This is a linear graph. You click on display equation, and as you say display equation, there it is. It's displayed over there. The last part is the R squared value. The R squared value, guys, is a value that tells you how close to a straight line was your graph. 97.1. So that's what it says. And now you can close this. There's your data over there. So from here, you can be able to just get and see the resistance of the conductor used was 0.58 ohms. Okay, sometimes you want to force the graph to go between 0, 0. You can also just click there. And this will force the C, the y-intercept, to be 0. But that's not what we want here. Ne? Or the second last one. Here now, we need to calculate the value of power. And we are given an equation. Power is voltage times current. We've got the voltage and we've got the current values. You put the equal sign. P34 multiplied by C34. Enter. So that will be the value. You just calculate for one. You simply just go to the bottom part until you get the black cross. Double click and it fills for the rest, irrespective of how many you've got. Now you've got voltage, current, and power. You are ready to plot your graph. To highlight, that's how we're plotting a graph. Insert, you go to again scatter graph, isn't it? This time we want to join the lines, so we've got to put one that has that joins the lines. So one of these lines have to be plotted on the right. We want to change power values to the right hand side. You can right click and then from there format data series. It's now on the primary axis. You see that? So you simply just move it to secondary axis and it turns out that's all we had to do. Okay. Now, the rest is history. I'm sure you can do everything else. Last one. Let's calculate sine of theta, and these are the theta values. And then you want to say sine, and as you type, you see that there's a sign there. It helps you. You click on that sign, you can double click on it, and it says, what will be the number? You see, that's my number. And then close the bracket, enter. And when you put it down, it says sine 90 is equal to 0.89. Do you agree with it? You need to inspect what you get. Look at this one. So this doesn't look like the correct values that you expected, isn't it? You need to change the theta value to radians. Pi is a function as well. Some of you will say 3.14, that's still fine. But pi, you see, the minute you say pi, it shows you there's a function that will return that value. Function comes with equal sign. We already have an equal sign. We can't have more than one. The name, and then open and close brackets. All the time. All functions have those two things. The name, open and close brackets. Pi divided by 180. And then enter. So let's try and see now. You see that's what we did there? Then we can write it down. Is sine 90 equal to 1? Now everything is fine. What we can do is, you can click here and say, I want this thing to be in radians. And immediately you say radians, it shows you there's a function that converts to radians. We're going to copy this text. Let's just show you how to be clever now. We copy this text, not the function. I didn't copy to go to the next part. Just copy that thing. Can go in there and paste and just change cos. Right click, paste, and just change 10. And then from there you simply highlight and put it down, and that's your values. Now, I've seen people changing or deleting this thing because they're asking themselves, what is that? But you realize that the 10 graph goes to infinity or to a very large number. That's why. In fact, if you just drag this thing out to realize that there's a number there, it's just that it's so big. Okay, you highlight. After highlighting, you go to insert, scatter with joint lines, and it looks nothing compared to that, no? Except that, of course, the legend is there. You need to change the scaling of the axis. This one goes from -1 to +1 only. This one goes to billions to minus billions. And what is throwing it out of proportion? You remember that big value of 10. So we want to change the scale of these numbers. So just right click on this, format the axis. We don't want the minimum to be automatically generated. We want it to be fixed to what value? -1. And the maximum must not be automatically done. It must be fixed at +1. And we look again, we realize that there's divisions of 0.5, isn't it? So we'll go here and say, even the divisions, now it's starting to look like it, you see. Even the divisions must be not fixed to 0.5. 5. And then you can close it. And there it is. So what are we learning there? We're learning, number one, that by default, you might get the values in degrees, not in radians. You need to convert it to radians. A little bit of maths there. Ne? Number two, I'm showing you something that you might be asked, even with other graphs. The scaling, how to change the scales. You'll see that even the bottom one goes from 0 to 400, whereas mine goes to 360. I'll leave that one for you to change to 360 in divisions of 45, 0, 45, 90, 135, and this one goes 0, 50, 100, 150. You should be able to change that because I've shown you with one of the axes.